All right, welcome to the normal form of a linear function. If you just listened to the earlier one, 7.5, this is going to be a breath of fresh air for you because it's a lot easier than we have. So let's just get right into it. The normal form is another way to write the equation of a line using trigonometry. We'll focus on converting back and forth from normal form, but I do need to give you a quick heads up of what it is we're talking about. Let's see if I get my cursor here. Okay. There we go. All right, so the normal form looks like this. X cosine phi plus y sine phi minus p. We use phi. I don't have an answer for it, but it helps us, or y, but it helps us distinguish between normal form and something else. I'm on page 463. If you want to turn to that, it might help you see this. First thing is what I need to do is I need to show you a line, and the normal to that line is what we talk about that right here. This, if I start from 0, 0, I come to here and I do a right angle. So it's really, a normal is another way of saying the distance between the origin and the line. And then what happens is I pull off the angle by starting from the x-axis and going to that. So that's my phi. And my distance is my p. And so I can give you phi and p, and you can write the normal form of a line, and that's really fast and easy. And so, but that's what they're talking about is here's my line. I could figure out this y equals mx plus b, or plot the points and 2 points to determine a line, and I get the equation of a line. I could put it in standard form, and going back and forth from the normal form to the standard form is what we have. I don't like if I said this was, if I said phi was, let's say that's 50 degrees, and I said p 1 2 maybe p equals 3, then I could write that equation as x cosine 50 degrees plus y sine 50 degrees minus 3 equals 0. And if I had like 30 degrees here, it might be easier even just to put it into like the square root of 2 over 1, or 1 over square root of 2 for 45, and using my 1 2 root 3 triangles for what. And didn't follow what I said, not a big deal. So in this chapter though, what we're going to be doing is we're going to be converting normal form to standard form and converting standard form to normal form. Here you just use your calculator or use your special triangles, and we'll get to that. I'll show you how that works. Here, going from standard form to normal form is a little bit tricky, but it's an easy pattern that I'll show you as we go through. You could come back and review to this on our step 3s when we do it. So let's look at 12. So we're supposed to write this in standard form, and really when they give us the p and the phi, what they're saying is that you started with x cosine 60 degrees plus y sine 60 degrees minus 15 equals 0. So when they give us that what they're really giving us is this right here. So that's not solving the problem. That's actually taking p and phi and putting it into normal form. So this is what we call normal form. So converting that to standard form is what we're doing. Now in standard form, since this is 60 degrees and it's an easy one for us to figure out, what you want to do is remember your right triangle, 60 degrees, 30, so that's a 1 2 root 3. So cosine, this will be x times the cosine of this is 1/2 plus y, the sine of that is sine of 60 degrees is root 3 over 2 minus 15 equals 0. So I'll put this up over here so that I could say that x over 2 plus root 3 y over 2 minus 15 equals 0. And if you want to clear your fractions, you could write x plus root 3 y minus 30 equals 0. And that's all you had to do. A different one with the 125 and a lot of square roots might have decimal answers for it. You don't need to have decimal answers. It depends on what we have, but I'm now looking at the book and I realize I made a mistake here. This is 135 degrees. So let's use 135, not 125. And so again, this is going to be x times the cosine of 135 degrees, and hopefully you recognize that as a 45-degree angle, and y times the sine of 135 degrees, and this is going to be minus 3 root 2. Okay, and so from there, what we want to do is use our special triangles, but actually I want to show you what happens when we don't use our special triangles. And so if I'm going to use my calculator here, if I could put in 135 and I could put cosine in, and I get this ugly number, and then actually you do want to use your special triangles here. I could put the decimal equivalent, so that would be like negative 0.707x plus, and whatever y is, I think that's going to be positive 0.707 minus 3 root 2. You would have all those there. So this wasn't the problem that we would just want to use our calculators on. You would need to remember that 135 is here, and that's a 45-degree angle. So that's going to be 1 root 2. So this will be x times not times cosine, that's what we just figured out. So cosine is negative, so that would be negative 1 over root 2 plus y, and then sine is 1 over root 2 minus 3 root 2 equals 0. And this looks tricky, but notice how I have root 2 on the bottom and that on top. So if I multiply everything by root 2, this cancels out, and I'm left with negative x plus y, and then root 2 times root 2 is 2, so minus 6 equals 0. So there's the equation of the line. And let me make some white space here for you. And so on here, hopefully you see this. So I'm looking at 16. You go, oh, that makes everything easier, because that's pi over 2. That's like 90 degrees. And then so if I look at my x times the cosine, I'm just going to convert that to 90 degrees so that you can see it. Y sine 90 degrees minus 2 equals 0. So what happens here is cosine of 90, remember, is 0, and sine of 90 is 1. So this is y minus 2 equals 0, or you could say y equals 2. That's the equation of that line there. Okay, hopefully this makes sense. And what I want to show you is, because I promised you could use your calculator too, what happens if I do pi equals 3 and phi equals 37. We don't have a known quantity for 37, so what I would do is I would go x cosine 37 degrees plus y sine 37 degrees minus 3 equals 0. And then I got to pull up my calculator. And so cosine of 37, make sure I'm in degree mode, is 0.798. Let's just go 0.799. So this is 0.799x plus, and then sine of 37 degrees is 0.602, 0.602y, and that would be minus 3 equals 0. It's ugly because of the decimals, and that's why they give us all these special triangles so we don't have to worry about decimals. But sometimes that can make it harder. So here, this is where things get a little bit trickier that we have to do, but there is a pattern for it. You have to know the pattern of solving these. It's really just a plug and chug question, and you could refer to your notes. You could also look on page 465. The first thing that we need to do is we need to put this in standard form, which means we have to have the 1 over here and it has to be equal to 0. So you want to do that first. And then what you're going to do is you're going to divide each one of these terms by a squared plus b squared, and we take the square root of that. And we're going to have a plus or minus here, and I'll explain the plus or minus as we go. So in this problem, you would have x, and I like to move things over to the right side. This is going to be the a, so it's going to be 1 over the square root plus or minus the square root of a squared plus b squared. I'm going to do this in kind of a couple steps so that you can see it. And this is going to be 1 over plus or minus square root of a squared plus b squared, and then minus 1 over the square root of plus or minus a squared plus b squared. Okay, so a squared plus b squared comes from the x and the y as long as they're on the same point. So that would be 1 and 1. So 1 plus 1, 1 squared plus 1 squared is really 1 plus 1 or 2. So this converts to x over 1 over root 2, hopefully you recognize that, plus y over, oh, I forgot the plus or minus, plus y over plus or minus root 2 minus 1 over plus or minus root 2. So I'll stop there and let you catch up. Okay, just realized I don't have to pause for you to catch up. You could you could pause it yourself if you need to. All right, so the first thing that we did was we figured out a squared plus b squared. Now let me talk to you about this plus and minus here. What you do is you choose the opposite of what this is. So this is c, and we think of it as, should have wrote this earlier, but ax plus by plus c equals 0. You choose it the opposite of this. So -1 here means I'm going to make this positive. So all of these will be positive. And that's important to know your angle, the correct angle that you have, which we'll get into in a minute. So those have to be positive. The other thing is now this is cosine phi, and this is sine phi. And that would be equal to this. So what that means is we're really looking for a triangle. Now cosine, remember, positive 1 over root 2 would be here. So this would be like 1 over root 2, or it could be down here, 1 over root 2. Well, sine 1 over root 2 could also be here, or it could be here, 1 over root 2. And what you're looking for is where is it equal to the same? Well, it's right here. And if you recognize that as a 1, 1 root 2 triangle, you know that's a 45-degree triangle. And so what happens is our problem becomes x cosine 45 degrees plus y sine 45 degrees. And then at this point, it's a little bit, you now have a negative over a positive, so it's minus 1 over root 2. The hardest thing about the answer is really the c. And then you could write equals 0. And there is your normal form of the linear equation x plus y equals 1. All right, let's do it for 24 now. Get some space here. I'm going to try to go a little bit faster so that you can see that it's actually hopefully it'll become an easy problem for you. But let's go ahead and move the 2x over, so I have negative 2x plus y plus 4 equals 0. Now, if you're wondering, well, what if I go on the right side versus the left side? You could do that. You'll end up with the same answer, but you'll have a plus where I have a negative, and they'll be the opposite until the final answer. And so the big thing is to know A, B, and C. So a squared equals 4, b squared equals 1. So we have the square root of 4 plus 1. So a squared plus b squared is going to be the square root of 5. Okay. And then, so on this problem now, what we have is we could rewrite this as x, and I'm going to put this over here, -2 over the square root of 5. Now, since c is positive, I'm going to write negative square root of 5. Sorry to make that ugly. And then we have plus y over, and this is going to be 1 over the negative square root of 5. And then we have plus 4 over negative root 5. So remember, the plus 4 told me that this was negative. Okay. Okay, I'm going to create some white space because we're going to do a little bit of work here and create that for us. Okay, so that's the first part, is really just figuring out a squared plus b squared, dividing by that, and then figuring out whether it's plus or minus. Now what happens here, since I have a minus over minus, I really have 2 over root 5, and this would be -1 over root 5. Because remember, this has to do with cosine phi, and this is my sine phi. And so now I'm going to look for my triangles where both of those will work. Well, cosine could be in either here or here. So that's going to be 2 over root 5, the 2 goes here, or 2 over root 5. Well, sine only works for the negative. It'll be here, -1 over root 5, or here. But now that it's not over here, I know it's not that, I know it can't be that, so it has to be this angle right here. And at this point, this is not a special triangle because we see the root 5. So what you're going to want to do is use either cosine or sine, but you want to recreate the triangle here, and we have 2, -1, root 5. We're going to find this angle using our trig, and it's as simple as, we could forget that it's there. I could go that the angle equals the inverse tangent of 1 over 2. It doesn't have to be -1 because we're just looking for a triangle. We're like solving the triangle. So 1 divided by 2 goes 1/2. I'm going to go inverse, where's my tangent? There's my tangent. And so that's 26.5 degrees. I'm just going to go ahead and round that to 27 degrees. So if that's 27 degrees on the inside, then 360 degrees minus 27 degrees is 333 degrees. So I could come back here and I could say, well, this is going to be x cosine 333 degrees plus y sine 333 degrees, and then minus, and then 4 over root 5. If I rationalize the denominator, I get minus 4 root 5 over 5, and that would be my answer. Equals 0 would be my answer for putting it in standard form. One more to do, and then we're done. Here I have root 3 minus y over 2. So, and I'm gonna show you. Well, no, I'm gonna move these over to the right side, and so I'll get 0 equals root 3x plus y plus 2. You can do that because if I kept it over on the left, what would happen is when I divide, it changes the signs on everything. You could try it if you'd like. But so a equals root 3, b equals 1, c equals positive 2. So that means a squared plus b squared. Root 3 squared is 3, 1 squared is 1. So it's 3 plus 1, and the square root of that then equals 2. Since c is positive, that's negative, so it's negative 2. So this becomes a little bit easier of a problem because I can now write, and I'm going to go with this part right here. I have x over, or times, root 3 over negative 2 plus y times 1 over negative 2 plus 2 over negative 2 equals 0. And so let's look at our triangles here. Again, this is cosine phi and this is sine phi. So cosine, the negative has to go up to the top, so we're looking at negative values for cosine, so it's one of these two triangles where I have negative root 3 and the hypotenuse is 2. The sine has to also be negative, negative 1 over 2, so that means it has to be here. It has to be here. I could have written the other triangle, but it's this angle right here. And this is a 1, 2, root 3 angle, so this is a 30 degrees. This is 180. 180 plus 30 is 210. So we're looking at 210 degrees. So I could write x cosine 210 degrees plus y sine 210 degrees minus 1 equals 0. So to me, these are the harder problems of this section, but they do follow a pattern that hopefully you could pick up pretty quick. But that's it. You're either going to convert from standard form to polar form. And when you look at the book, forgot to mention this, but they just give you phi equals 210 degrees, and then they'll say p equals 1 or negative 1, depend, like in this problem. I think it's 1 because that's a negative there. And or you're going to go from that and plug it in and solve. So good luck. See you later.